Okay, in this video, we are going to begin solving systems of equations algebraically. And there are two ways to do that, as we're going to see. But the way I want to begin is I want to begin by reviewing what we just learned about graphing systems of equations, because the results are the same whether you're solving them by graphing or solving them using algebra. So when you solve a system of equations by graphing, you only need to graph both equations and see whether you have first opportunity, one solution where the lines cross, no solution where the lines are parallel, or infinitely many solutions where the lines are the same. You can feel free to pause this video at any time so that you can copy or screenshot these graphics. However, solving systems algebraically, you can only solve for one variable at a time. It's been that way since we started the school year. When we did our linear functions unit at the beginning of the unit, we learned right away that you had to have an input for x, or you had to be given y and then solve for x. You cannot solve an algebra problem for more than one variable at a time. Since you begin with two variables, x and y, you need to find a way to hide one of the variables so that you can solve for only one. Then you take that solution, plug it into the other equation, and solve for the other variable. If you have a solution, you write it as an ordered pair. Parentheses, x, y, parentheses. There are two methods that we use to solve systems with algebra. One of them is called substitution, and the other is called elimination. First, we will learn substitution. That's what this lesson is about. In substitution, we use our literal equation skills that we've already learned and been practicing since September to isolate one of our variables. Then you substitute the rest of the equation for that variable. Here's our example that we're going to be working on. You can see two linear equations right next to each other. X plus 4y equals 3, and negative 2x plus 3y equals negative 17. So a word about substitution before we dive in. You only want to choose this method of solving systems if this case that I have in a blue box with exclamation points, if you have this scenario, then substitution is a slam dunk, easy way to solve a system. You need to look for a variable that has a coefficient of 1. Here we have one right here. That's why I drew the blue box around it. So then you want to isolate that variable. And you can see that I've got space right here to do just that. So how do I isolate x? You guys know we have to get this y term to the other side of the equation. So I'm going to cross that off there. Way too thick of a line. And then I'm going to rewrite. Now I have what I need. I have x isolated, and I have it equal to a piece of the equation. Now you have a chunk of the equation that equals one of your variables. In this problem, x. Then take the chunk of the equation and put it into the other equation in place of x. So you see here that I've got a blue box drawn around my chunk of one of the first equation I started working with. And then you see I drew a blue box around this x in the other equation. That space is where I'm going to put this. And in the next frame down, you see that's what exactly I did. I substituted this negative 4y plus 3 in place of x. Note, now I only have y. One variable. We can now solve this equation. So let's do it. So now you see, this is a very important note. You see we now have a multi-step equation. Look at this. We've been doing these since August. Very, very simple. We distribute our multiplication. We combine like terms. We isolate the variable. So let's do that. Negative 2 times negative 4y is positive 8y. And negative 2 times 3 is negative 6. We then have plus 3y, and the whole thing equals negative 17. Well, we know what to do now. Combine like terms. So that gives us 11y minus 6 equals negative 17. Next step, isolate the y term. Add 6 to both sides. And then we end up with 11y equals negative 11. Very simple at this point to finish. We divide both sides by 11. Okay, and we end up with our y coordinate. Y equals negative 1. Cool. We're halfway there. Now that we have y, let's look at our two original equations again. Choose one. I always choose the simplest one, and I suggest that you do too. You substitute the value in for y and solve for x. We discovered that y equals negative 1. So in place of y in this original equation, I'm going to put negative 1. Take a look. You can see that now we have one variable. We can solve this. So let's do it. 4 times negative 1 is negative 4. So that gives us x minus 4 equals 3. Isolate x by adding 4 to both sides. And voila, we have x equals 7. We have now solved our system, and we can write this solution as an ordered pair. X, y, right? So we're going to write 7, negative 1. You may, and I suggest that unless you're super sure about your math, you can take these variables and plug them back in to one of these equations, and you'll find out that they work. They make it true. So there you have it. And there's the bell. See you in the next video.